Hi, this is Mr. Hansen. I want to look today with you at two things. Arc length. An arc is just a portion of the circumference of the circle. And then a little bit later on in this video, I want to look at sector area, and that's kind of like a slice of pizza out of a circle. So a sector would be the triangular slice of pizza, triangular looking, but on the part of it's going to be curved there. So let's start with the arc length, and before we get to that, we're going to do some very basic stuff. You might remember from 7th grade that if you had a diameter and you measured it in string and then you kind of wrapped it around here, it'd go one time, and then two times, and then three times, and then a little bit more. And for any circle, it's always the same ratio. The circumference over the diameter always equals about 3.14, and in more exact terms, it's called pi. So let's just write that down here. Circumference over diameter equals pi. And we can manipulate this formula a little bit. We can exchange diameter with, well, let's do this. C over 2 radii equals pi. So we just exchanged 2 radii for a diameter because you can kind of see two of them here. And then finally, let's get C alone so we can kind of work with figure out what C is. So I'd times both sides by 2r, and C equals 2 pi r. So the distance around a circle is 2 pi, which is 6.28 times the radius, or 1 pi times the diameter. Okay, so now that we've kind of established that, what if we want just a little bit of distance? Let's say this much right here, something like that. And you might remember, in terms of radian measures, 2 pi is the distance all the way around the circle. So we're going, this is a fourth of pi here. So it's kind of like 45 degrees, pi over 4. This would be 2 pi over 4, 3 pi over 4, 4 pi over 4, and so on, 5, 6, 7 pi over 4, all the way to 2 pi. And so if we're looking for this length right here, all we need to do is think of it as a portion of 2 pi. And so this is the portion of 2 pi. It's 1/8 of 2 pi. And then we just need to check out the distance of the radius. So the radius, if it was 5 in this case, it'd be 5 times pi over 4. And you would get 5 pi divided by 4, 3.92, about 3.92. So hopefully that helps you kind of understand what's going on there. So let me give you a formula for arc length. It's just the angle measure in radians. We had pi over 4 times the radius. That's all it is. So the angle measure in radians, that gives you a portion of that 2 pi. And then we just times it by the radius, and we have we scale up that circle. If the radius is 3, it's bigger, 4, it's bigger, and so on. Or we scale it down. So it's the angle measure in radians times the radius, and that's the arc length. So let's just practice one. Let's say that you had a circle, and you've got something like this. And this is going to be, let's say 225 degrees all the way around. So you want to know the length of that arc right there. So 225 degrees, and the radius is 4. So we could plug in place of theta. Well, we'll talk about that in a minute. The radius is easy. It's 4. And you might remember converting degrees to radians, so 225 times pi over 180. And in my calculator, I'm getting 3.92. So that's about 3.92 radians. That makes sense if all the way around is 6.28. That looks like about 3.92. So you just go 3.92 times 4. And we get 15.7. So there you have it, 15.7. Hopefully that makes a little bit of sense to you there. And I guess a question might come up, when would you need to find arc length? So whenever you have circular boundaries, that's kind of like if you had a circular fence you had to put up or something like that, or part of a circular fence, then you could determine the arc length. Okay, let's take a look at sector area. So a sector is a filled in portion of the circle. It starts at the center and it has two rays going outward, and then you just kind of filled in there. So let's think about the whole area. The whole area is pi r squared. And we're going to set up a bit of a ratio here. I've got it kind of set up down here. We've got part over whole. And so if we're talking about the circumference or the distance around the circle, the whole is 2 pi r. And the part is theta r. That's kind of what we just established a minute ago with arc measure. Okay, so we have that. And then for the area, the whole is pi r squared. And then the sector is kind of our unknown piece. It's our variable. So you could even put x there or something like that. That's what we're solving for. Okay, so let's look at the circumference again, and we can cancel out the r and the r there. Okay, so the r is just kind of enlarging or shrinking down the circle, and this is the main property here is the theta over 2 pi gives you a portion of a part to whole for the circumference. Okay, so let's go ahead and do some cross multiplying. We've got theta times pi r squared. So theta times pi r squared equals 2 pi r times, we'll call it x, that's our sector length. So we multiply those. And let's divide by 2 pi r. I'm sorry, just 2 pi because we already crossed out the r's. That shouldn't be there. So let's divide by 2 pi. And now we have theta times r squared divided by 2, and that equals your sector area. So let's clean it up here. Sector theta r squared over 2. That's the formula right there. And so let's just take a look at this one. And let's say that the radius is, let's say it's 3. So we got 3 there. And let's say the angle measure is, let's say it's 3.14. Let's say it's about 1.9 radians, about 1.9 from there to there. So we're going to go 1.9 times 3 times 3 divided by 2. And that'll give us all the square units inside of here. How many little squares are in here? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm guessing about anywhere between 10 and 14. I hope I'm close to right. 1.9 times 3 times 3 divided by 2. Oh, I wasn't even close. It's 8.55. So that would contain 8.55 units squared. Okay, let's talk about when would you use the area of a sector. You may, flying an airplane, maybe you've looked down if you've flown over the Midwest and you've seen all these crop circles. They might need to know how much area those crop circles cover. These circles come from sprinklers that rotate, and so they might need to know how much area, and maybe they have something like this, and they need to know how much that crop circle covers. Okay, that's one example. Of course, I always think of pizza. You could figure out the area of sector for pizza. And there's probably lots of other things that you could think of. Let's do one last one. This time I've got this is oh, you can kind of tell that it's 270 degrees worth of circle, or in terms of pi, it's 3/4 of 2 pi. So 3/4 of 2 pi, and that's 6 pi over 4, or 3 pi over 2. Okay, so 3/4 of all the way around the circle. And let's say the radius is 9 this time. So all we have to do is, hopefully remember from the last slide, r squared times theta divided by 2. So theta is 3 pi over 2. 3 pi over 2. R squared, we're going to go 9 times 9. And then we have to divide this all by 2. You can just put 2 in the denominator there. And so we've got 81 times 3 pi divided by 4. And you end up with about 190.85 centimeters. And since we're dealing with area, it'd be centimeters squared. Hope this helped out a little bit. Thank you.